Okay, welcome to proportions. Now, proportions is simply when we set two ratios equal. And remember, ratios is just a fancy way to say fractions. So an example would be 1/2 is exactly the same as 3 divided by 6. They are both, the 3 is half of 6, 1/2 of 2. So this would be an example of a proportion. We can also introduce a variable, and we could maybe say that 1/2 is equal to what part of 8? And then of course, obviously you could solve this fraction by multiplying by 8 to both sides. X divided by 8, so we use multiplication to solve for that. Multiply 8 to each side. 8 divided by 8 is 1. So therefore, x equals 8 times 1/2 being 4. So fairly easy. Another example that we could look at might be something like this. Let's say 220 over 33. This is one ratio. When we set it equal to another ratio, say 60 over the letter D, this is now a proportion where we have two fractions or ratios equal to each other. Here we want to solve for D. One easy way I like to solve for this is I'm going to find the reciprocal first, because I want D up in the numerator. It's much easier to deal with D when it's up in the numerator because there's only one step to solve here. But then I have to find the reciprocal of this fraction as well. Then here, just like in the previous step, D divided by 60, it becomes easy to multiply by 60 to each side. And then here, with a little work of our calculator, we find that D is equal to 9. Sometimes we might have an application problem. Here I have an application problem. I'll read it if it's too difficult to see here. Diana has a large stack of playing cards. She knew that 17 of them were kings, and she took a sample of 30 cards and found 4 kings. Approximately how many of the playing cards does Diana have? So here what we can do is set it up. She found 4 kings out of the 30 she chose. So here are the kings out of the total that she chose. And we want to set it equal to another potential fraction. Now she knows there's 17 kings. So I'm going to put that up here where I have kings on top over the total she chose. Well, this is going to be the kings on top that we know are there over, let's say, x, which is the total. So one thing that's important is comparing, like here I have kings to the total cards. Over here I also want the number of kings to the total cards. So when we set up our proportion, it's important to have the things in the numerator mean the same value and whatever's in the denominator mean the same value. So here, to set up this, once again I have x in the denominator. One way to solve for this to get x out of the denominator would be to multiply by x, because 17 is divided by the x, so I could multiply x to both sides. But I prefer just taking the reciprocal, because x over 17, if I flip this reciprocal, or flip this fraction, or reciprocate it, I do the same thing over here, put the 30 up on top now in the numerator, over 4, and then it becomes easy to solve, where we have times 17 to each side. Now it's x divided by 17, so we use the inverse of division to solve. 17 divided by 17 is the number 1, so we have 1x. Using our calculator here, we get 127.5. Now, this being a silly number of cards, you can't have half of a card in a deck. We would change our answer, maybe round it up to 128 cards is approximately how many cards she has by setting up our proportion like this.